Yeah, so good morning. Some minor issues today. Amit is not able to do the class for you all. So I'll just work on it. So we will work on we were working on current electricity. So we just continue with that. So I hope you all have your physics notes with you and then you can write. So we were working and we did a couple of questions based on cells. So we continue our learning and understanding. We will do more questions on Kirchhoff's law. So don't worry. If you don't understand, you'll get a lot of opportunities to understand. So let us work with cells. Okay, so this is the next portion. If it goes at this rate, maybe within another 3 classes, I'll be finishing off with this chapter. So those of you who are yet to start working, please start working. And others, those of you who have already finished working, then good, you wait for the next chapter. Within the next 3 days, we will start the next chapter, that is moving charges and magnetism. Okay, so let's work with cells. So basically a cell is a device that maintains a potential difference. Okay, say for example, suppose typically this is a cell that you have. Suppose I take a container. In the container I have copper sulfate, copper sulfate. Okay, so suppose I dip a zinc rod. Suppose I dip a zinc rod. Now you guys know that zinc is more electropositive than copper, or zinc is more reactive than copper. So if you look at the activity series, zinc is much above copper, copper is below hydrogen, zinc is much above hydrogen. So you have K, Na, Ca, Mg, Al, Zn. Okay, then you have Fe, iron, cobalt, nickel, and so on. So you have zinc right here. Then you have hydrogen. After hydrogen, you will have maybe lead, and then you will have copper. So copper is below hydrogen in the activity series. So here you have a situation where zinc is much more reactive than copper. So if the moment you put this, what happens is CuSO4 plus zinc gives ZnSO4 plus Cu. Okay, so displacement reaction takes place, and zinc displaces copper. So if you look at this, what is happening is you have copper 2 plus zinc becomes zinc 2 plus copper. So what mankind said is, suppose I separate these two reactions. So effectively, this is the reaction that is taking place. So what Volta did is he just saw a mechanism to separate these two. So how did he think of a mechanism to separate these two? So what he did is he took one container and he took one other container. Okay, in this container he had copper sulfate, and he had a rod, copper rod. In this he had zinc sulfate, and he had zinc rod. He made sure that there is a connection between these two. Okay, and what he did is he took a wire from here and he took a wire from here, and he tried to connect them. Okay, so when he tried to connect them, he saw that the reaction still happened. So in the solution, the Zn2 plus concentration increased. In this solution, the Cu2 plus concentration decreased. So what he did is he created an artificial barrier between the two ions, and then the reaction still took place. So this was the first cell that was made way back in the early 1800s. Early 1800s, this was the first cell which was made, which is called the Daniell cell. Okay, so in a Daniell cell, a simple displacement reaction is taking place where copper sulfate reacts with zinc to form zinc sulfate and copper. Now, because there is a huge difference between the activity of these two elements, what happens is that it was possible for us to see if these two reactions can be separated, because effectively the reaction taking place is a combination of electrons with copper and the release of electrons by zinc. So when these two were separated, he saw that the reaction still took place, and this was the first cell made by mankind, which is called an electrochemical cell. In this electrochemical cell, what happens is there is a potential on this side for the copper to accept electrons. There is a potential on this side for zinc to release its electrons. Okay, and you have physically separated these two reactions by making sure that they are in two different cells, right? So this is what is an electrochemical cell. Yeah, so this is what is an electrochemical cell. We will learn more about this when we do chemistry, so we don't want to ask too many questions now. So in an electrochemical cell, what happens is you go to the market and you buy a battery. So this is one terminal and this is the other terminal, and if you connect them, the electrons will flow from one side to the other side and a reaction takes place. Okay, in between there is a separation such that these two are not reacting together because of electron transfer within itself. Yeah, so this is what we go when we go to the battery and buy a cell. This is what happens. Now what does a cell do? A cell basically drives electrons to go from one end to the other end in the external circuit, and for that it makes sure that there is a potential difference, because charge will flow from one point to another point only if there is a potential difference. So if there is no potential difference, charge will not flow. So the only way he can make we can make it do is that keep a battery. So a battery ensures that there is a potential difference between the points. So 3-volt battery ensures that there is a potential difference between the point. As long as there is chemical inside the battery, the reaction would want to take place. And as long as the reaction wants to take place, the potential will remain the same or very close to the same. It changes, but by very little. It will always be above 2.7, 2.8 and very close to 3. So this will be the case always. When the battery dries off, the potential will come down. When the chemical is over, the potential will come down and ultimately it will become 0. Even if there are 10 molecules, the potential will still be 3 volts. It is not that the potential is dependent on the volt. The potential is dependent only on the reaction that is taking place. So in our case, Cu2 plus zinc will give you Zn2 plus Cu. Now this will give a potential difference of approximately 1.4 volt. So whether there is one atom or whether there are 100 atoms or whether there are 1 million atoms, the potential will continue to be 1 volt. What is the difference is the number of electrons which goes. So the current into time is governed by the amount of the chemical substance which is there. So if I have a battery which will last 10 ampere hours, that means there is enough chemical for that battery to give 10 amperes of current for 1 hour. That means 10 ampere into 60 minutes into 60 seconds. That means there are so many electrons there are so much of charge moving, that is 6,000 coulombs. And 6,000 coulombs, this is how many electrons divided by 1.6 into 10 power minus 19 electrons. So this will, I'm just showing you some calculation. So this will become like 10 power 23, 10 power 22 and 22, 16 into 4 approximately. So approximately 4 into 10 power 22 electrons are going from one side. That means if you have 1 mole of the substance, little less than 1 mole of a substance, this is happening. So I can do calculations and I can make sure that I have a battery with the required chemical which will last the amount of time that you want me to do. What is happening is the battery does the job of maintaining the potential difference, right? And this potential difference ensures that a current flows in the circuit. The current is not consumed because there's a reaction taking place. So on one side copper is taking the electrons, zinc has to give the electrons. So if zinc doesn't give the electrons, copper can't take the electrons, right? And if copper can't take the electrons, the reaction won't proceed and it will stop. The battery won't function. Yeah. So that is why I kept on telling you that in a circuit current is not consumed. Current is not consumed. It is the energy which is consumed in the circuit. Okay, so please understand that and remember that. Okay, now what do we want from a battery? Now we have to understand that in a battery, so in a battery charge moves. Yeah, so when in a battery charge moves, every battery will have some internal resistance. Okay, every battery will have some internal resistance. Why will it have internal resistance? Because in the battery some ions are moving. Okay, so now this internal resistance of a battery will depend upon one, the nature of the chemicals. So in a Daniel cell, it is zinc and copper ions. In a lithium battery, it is the lithium plus. The sizes are different. When the sizes are different, they will have different resistance. So it depends upon the nature of the chemicals. Two, it depends upon the distance between electrodes. The internal resistance depends upon the distance between electrodes. The internal resistance also depends upon the area of the electrode immersed in the electrolyte. Say for example, if I have an electrode only this much immersed, and if I have an electrode this much immersed, so here you see more ion electron transfer can take place. So here the resistance is low. So I have R is equal to rho L by A. This is the resistance. So resistance is directly proportional to the resistivity. Resistivity depends upon the nature of the chemicals. Then resistance is directly proportional to length. So as distance between electrodes increases, resistance increases, and it is inversely proportional to the area. As the area increases, resistance decreases, and vice versa. Okay, so this rule is valid even for the internal resistance of a cell. Internal resistance of a cell refers to the resistance which the electrolyte of the cell offers to the flow of ions and electrons within it. Okay, so it primarily depends upon these factors. Of course, it will also depend upon temperature. As you increase the temperature, the ions will have more energy. As they have more energy, they will travel faster, so they will have low resistance. Okay, but we are not talking about that. We are talking at a given temperature. These are the fundamental aspects on which resistance will depend on. Okay, now moral of the story: every battery, depending on the reaction which is taking place, has a potential difference. Now this potential difference is referred to as EMF, electromotive force. Electromotive force. It is the force which is developed to move electrons from one terminal to the other terminal. Okay, so it is referred to as the EMF. EMF of a battery. So if you take a Daniel cell, I said 1.41. That is the EMF of a Daniel cell. Now this EMF decreases as the Daniel cell is being used. It decreases once all the chemical is consumed. Then it becomes equal to 0. Sir, we are not informed about physics class now. Can you please share the timetable? Yeah, nobody was informed about this. I told you math sir is not able to come. So your audio is very low, screen lagging. Why did Volta discover a cell and name it Daniel? Oh, it is not one person who discovers. It is a group of people who discover. Volta didn't call it Daniel. It is the scientific community which later called it Daniel. Okay, Charles' law was named Charles' law not by Charles. Charles' law was named Charles' law by the scientific community. Ampere didn't say current is called 1 ampere. It was the scientific community in respect of Ampere called it as Ampere's law. So Volta, Daniel and all these were the first scientists who were doing the work. It is the scientific community later which said we can't call it Volta because we are calling it Daniel. So in respect of Volta, we will give volt. The unit of EMF as volt. Okay. Today, is this the last class? No, afternoon classes are all. Yeah, don't worry. Okay. Okay, friends, then you better leave it. You leave it now. We will meet in the afternoon and then we will carry on with the classes in the afternoon. Okay. So, yeah, I'm sorry for this. You don't have your notes also. So, leave it. We will meet in the afternoon and then we will work in the afternoon. Yeah. Okay.
Okay, sir. Thank you.
Yeah.
So, students, in the afternoon, then you will have a chemistry class, and after that, you'll have the physics class too in the afternoon session. Thank you.